Right, here is what I started to prelude to earlier, where these tables, yes, it's easy to pull individual probabilities from them, but they're also very helpful when you're trying to find a range of probabilities. And this is where we get that inequality notation going. I wrote this earlier. P of X equaling 2 means that we would be looking at the probability that the outcome was exactly 2. All right, exactly 2. Whereas if we have this notation, you're unfamiliar with inequalities, this is the greater than or equal to symbol. Think of it like an alligator's mouth, if that helps you at all. It's opening towards the larger value. So here we're saying X, whatever X is, it's some number has to be greater than or bigger than 2. The line underneath means it could also equal 2. So this is 2 or bigger. So equaling exactly 2, but also everything greater than 2. So let's look at an example. Suppose the random variable X, shown below, represents the number of times a person received a speeding ticket during a certain period. Sorry. P of X, the probability of X, represents a randomly selected person would have that exact number of speeding tickets. So here, ask yourself real quick, what's the probability that someone received no tickets? Now let's write this down. All right, 0.3726. 0 tickets had a probability of 0.3726. Now let's use our notation as we answer the following questions. The probability that a randomly selected person received 3 tickets, exactly 3 tickets, not more than 3, not less than 3, not at least 3, not at most 3. All right, it says they received 3 tickets. So that's the probability of our random variable, which here is the number of tickets, equaling 3. Now, I don't want you to get thrown off that there's 2 equal signs in our situation now, because what's in the parenthesis there is strictly describing which variables you're looking at. Is it a range of values? Is it exactly one value? And in this case, it's exactly one value. We want to look where the random variable is equal to 3 only. All right, and the probability of them having exactly 3 is equal to 0.0721. So again, this is the information equal to the probability. So don't get thrown off that there's 2 equal signs, because this one is contained just describing which X we're looking at in those parentheses. All right, what's the probability a randomly selected person has received 5 tickets? Again, an exact amount. P of X is equal to 5. We're looking at exactly 5 tickets. That's going to equal 0.0315. All right, what is the probability that a randomly selected person has received more than 0 tickets? P of X being more than 0. Let's think about what inequality this means. All right, is it at, well, there's only so many ways we can do this. And after you do a few of these, you can start to almost make like a key for yourself if you are someone who struggles to take words and put them into notation. If we have more than, that is going to be a strictly greater than. No or equal to, they're saying more than 0, meaning at least 1. So strictly greater than 0, more than 0. Value-wise, this means I'm looking at any number that is bigger than 0 or more than 0. So that's 1, 2, 3, 4, and 5. All of those would be more than 0. So one way to find this, much like with our frequency tables, we did similar things like this. We would add the probability of it equaling 1, plus the probability of it equaling 2, plus the probability of it equaling 3, plus the probability the number of tickets equaling 4, plus the probability of the number of tickets equaling 5. You have to add all of those together. That's a lot of decimal places, right? It's kind of a lot to write, okay? And you can do it, but if I'm typing in all of these decimals and adding them all together, I have personally, at least, a lot of room for mistake. I make those silly mistakes too often. So instead, I'm going to talk for the first time in this chapter about that complement rule we discussed in chapter 3, right? If I want something to be strictly greater than 0, well, because all of my values add up to 1, this is the same thing as 1 minus the probability of x being less than or equal to 0. Here it was strictly greater than. Less than or equal to is that exact opposite sign. One of them has to contain the or equal to, the other has the flip sign. And you can see it here. If all of these add up to 1, then it's going to be 1 minus this probability that's not included in my values. And that actually, with x being less than or equal to 0, well, our random variable can't take on negative numbers here. All right, so there is no less than 0. This is strictly equal to 0 going on here. This is 1 minus 0.3726. And if I type that into my calculator, I'm going to get 0.6274. Again, you could have found that by adding those other numbers. Go and check it. Add up all of these values together, and you should get that value exactly. But this was a lot easier to subtract out than it was to go through and add the other 5 values. All right, last one for this example. Sorry, it's a little bit of a long one. We want the probability a randomly selected person has received 2 tickets or less. All right. Let's say number or less to keep it more generic. All right. Well, think about what this means. Could they have 2 tickets that says 2 tickets or less? You say, yeah, 2 tickets or less. That's 2 or less, meaning that we will have a number smaller, so a less than sign, but also or equal to, because it could equal that value as well. So the random variable, the number of tickets we're looking at, needs to be less than 2, but it could also equal to, less than or equal to 2. All right, numbers that meet this requirement. This is how I always think of it when I go to do these. Okay, less than or equal to 2. Or 2 tickets or less. That's 2 tickets, 1 ticket, and 0 tickets. So we're just going to add the 3 of those together. 0, 1, and 2. We could look to maybe use the complement again, but at this point, 0, 1, and 2 is not that many to add. We have to either add up these, or we would have to subtract out these. So it's going to be 3 numbers either way. It's not any more convenient to look at the complement and subtract it instead. So we'll just add these 3 values. 0.3726 plus 0.2853 plus 0.2061. If I go to add those together, I'm going to get 0.864.